Let's find the missing angles of this triangle using different techniques. We can see right here, this 110 degrees is part of an inner angle made by this line, creating two separate triangles. But we also know that a flat angle like this one equals 180 degrees. So even though this angle looks like it's kind of just in the middle of the triangle, we can connect it back down here to 70 degrees because this whole angle must be 180 degrees. Because this is a right angle triangle and we have a 90-degree corner right here, we can now figure out the angle on this inner side of the triangle. It's going to be 20 degrees because that totals to 180 degrees. That is really all we can do at a simple glance, but there are still several other techniques we can use to find the rest of the sides and angles. The first thing I personally would like to do is the Pythagorean theorem, because it's simply easier than some of the other rules and laws we can follow. The Pythagorean theorem tells us that a squared plus b squared equals c squared. Well, what are our a, b, and c? We kind of get to decide. C is, by the rule of the theorem, going to be our hypotenuse. And our A and B don't really matter. It's going to give us the same answer. For this particular problem, I'm going to say that the 6 is A and this 9 is going to be B. That means that 6 squared plus 9 squared equals C squared for our hypotenuse. 36 plus 81 equals c squared. We need the square root of both sides. We can plug this directly into the calculator to tell us that 36 plus 81 square root of the whole thing equals 3 root 13. That is going to be our angle or our side for the hypotenuse. 3 root 13. We now have all of the outer sides, but we still have an inner side, these two halves right here, as well as some angles. The next easiest formula that I personally would like to use is going to be the law of sines. The law of sines tells us that sine of A over A equals sine of B over B equals sine of C over C. And you can use any two combinations of these depending on what angles and side you have. The angles and sides match together in sets. Because this little a is over here, the angle opposite it down here is going to be angle A. This is our angle C, and up here is our angle B. What we need to do to properly use this formula is figure out what set A and A, B and B, and C we have. Well, for this particular triangle, we know that angle C is 90 degrees, and we know that this side right here, little c, is 3 root 13. That tells us that sine of 90 over 3 root 13 equals sine of something over something. We can choose what we want to do for the next one. Because we have been given this lovely side right here, I think I'm going to choose to find what the angle of A is going to be. That means sine A over 6. Using some simple algebraic manipulation, I'm going to multiply both sides by 6, move it over here, and end up with sine of A equals 6 sine 90 all over 3 root 13. Well, while we can plug this into the calculator and get a number, it's not going to give us angle A because on the other side we have sine of A. But we can use inverse laws to have sine inverse of this whole function right here is going to equal our angle A. And we can now plug this entire thing into the calculator. First, you have to make sure you are in degree mode because we are finding the angles of this triangle in degree. My calculator is already in that mode. So what we have is going to be sine inverse of 6 times sine of 90 all over 3 root 13. And that is going to equal 33.69 degrees. That is going to be our angle A. 33.69 degrees. Well, we now have the ability to find the rest of the angles of our triangle. Because we know that these angles here must equal 180 degrees, we can know that 180 minus 90 minus 33.69 gives us 180 minus 90 minus 33.69, 56.31 degrees. That is our angle B. And this little inner angle right here is going to be 36.31 degrees because it adds up total with this 20 to the 56 degrees we have. We now have all the angles in the triangle, but we have some sides left. We have this inner side here that we could argue is the hypotenuse of this smaller triangle, and then we have this 9 is the total side angle, side of the bottom of the triangle. Therefore, this half and this half still need to be found too. The next thing I'm going to do is going to be some simple trigonometric rules, because that is going to be able to give me this right here and this right here. And once I have this, all I need to do is 9 minus this value, and we will have what this side equals. Well, following SOHCAHTOA, that tells us that sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. Well, we can use this exact formula, or this little acronym here, to figure out what this side is. This side of our little triangle is going to be our hypotenuse. We know that this angle right here is 6. We know that this is going to be another star we need to find. This is 70 degrees, this is 90 degrees, and this right here is 20 degrees. We can figure out the hypotenuse by using either sine or cosine. Well, cosine needs the adjacent side, which if we are basing this formula and calculation off of the 70 degrees, this is going to be our adjacent side. We don't have it yet, but we do have our opposite side. So that means sine of 70 degrees equals opposite, which is 6, over the hypotenuse. Again, we are going to do some simple algebraic manipulation, multiply both sides by h, divide both sides by sine of 70, and we end up with h equals 6 over sine of 70. Well, we can plug this straight into the calculator here. So I'm going to do just that. 6 over sine of 70 gives us 6.39 for the hypotenuse value. So that is going to be this one right here, 6.39. Well, at this point, we can now use the Pythagorean theorem if we choose, or we can continue using the trigonometric functions. I think I'm going to stick with the trigonometric functions because I already have this little triangle drawn out for me. What I want now is going to be the adjacent side. Well, to find our adjacent side, we can use either cosine or tangent, which we do have the ability to do both, because cosine would need the hypotenuse, which we have, and tangent would need the opposite side, which we have. Deciding between the two comes down to personal preference. For me personally, because the formula or the problem itself gave us this 6, I'm going to choose that over the angle I calculated, because if this side right here is wrong, it's going to give me the wrong answer for this side as well. But we know for a fact this is right, because we were told it's right. So tangent would tell us that tan of, we're still using the 70 degrees, equals the opposite over the adjacent side. Well, the opposite side is the side we're using, which is 6. And the adjacent, we're just going to leave that as an A. We used the exact same algebraic manipulations we did last time to leave us with A equals 6 over tan of 70. Once again, we plug that into the calculator, and it tells us that 6 over tan of 70 equals 2.18. That is this side right here. Now all that is left is this other side over on this half. Well, we know that the total is 9. So 9 minus 2.18 is going to leave us with 9 minus 2.18, 6.82 for the final side of the triangle. And just like that, we have all sides, all angles of this triangle, and we use several different trigonometric techniques to do so. Good luck with your studies, and I will see you next Monday.